Good morning. Today is Tuesday, January 12th, 2021. We are still with the statistics unit. We're on lesson 2, topic 2, outliers in data. Now, an outlier is a number that in your data set is widely separated from other numbers in that data set. So in the example on your page for your notes, this is statistics lesson 2, outliers in data handout. If you have my email, you have a digital copy of this. The outliers in the example are 5, 6, well, not so much the outliers. The data set is 5, 6, 9, 4, 7, 52. Now, an outlier is a number that doesn't make sense. It doesn't fit the data set. It's just a widely separated number from all the other pieces of data. In the 5, 6, 9, 4, 7, 52 data set, 52 would be considered the outlier, because it doesn't fit the data. Now, can you remove the outlier? Yes. You can remove the outlier to calculate your data set to give you the proper mean, median, and mode. If you keep it in there, it's going to skew, which means it's going to mess up your data. So let's think about example 1. You want to determine the price of a house in the Charleswood area of Winnipeg. You randomly select the prices of 10 houses in the area. And I'm not going to list off the prices to save some time, but there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data in that data set. So to find the mean, again, I'm not going to write all of them down to do that. It would take too long. To find the mean, you add up all the numbers in the data set. Then you divide by how many there are in the data set. In this case, you add up all those numbers and you divide by 10 because there's 10 pieces of data in that data set. And that will give you the mean or average value of those houses. Then B, find the median. Again, to save some time, I'm not going to write out the numbers in order from the smallest value of the house to the largest valued house. That's what you would need to do, is rewrite them in order from the smallest value house to the largest. And the median would be the middle value. In the case of the mean, I should actually help you by that there. If you did your math right, you're going to get $474,420 as the mean or average cost. In the median, you take all your values there, put them in order from smallest to the largest. You're going to get two values that will be considered in the middle. $331,200 and $364,600. Now, because they're both in the middle, you add them up together and divide by 2 to give you the proper median, which would be $348,150. The mode means which value appears more than one time. In the case of these 10 pieces of data in this data set, there is nothing that is duplicated more than once, so there is no mode given. Now, D says, what's the outlier? Well, what is the house value that really sticks out in this data set? And that happens to be the $1,799,000 house. That is your outlier. So you can remove that from your data set and you can calculate out the mean, median, and mode correctly, because that piece of data is an outlier and it's skewing your data. So E says, which measure of central tendency would best describe the typical house price in Charleswood if you include the outlier in your calculations? Well, to be quite honest, if you use the mean or average house price, it's too high if you include the outlier, as it is greater than the majority of the houses. 9 out of 10 of the homes prices are nowhere near being the mean if you keep in the $1.7 million house. It would tell you that the mean would be $474,420. The median would probably be your best bet because it doesn't even incorporate the idea of the outlier being involved. It is your middle numbers, and when we have to do that for the median, we had to divide by 2 because we had two numbers that were in the middle. The $348,150 median value would probably be the best bet for you to go with. I'm going to pause, and then we're going to talk a little bit more about the effects of outliers on the median, the effects of outliers on the mean, and on the mode. And then we're going to do example 2. So the effects of outliers on the mean, finding the correct average. If there are more than one outlier in a data set, the mean will strongly be affected by these outliers. If the outliers are significantly greater than the rest of the data, then the mean will be higher. If the outliers are significantly smaller than the rest of the data, the mean will be lower. Now the effects of outliers on the median. Outliers can affect the median, however, the median will still remain relatively unchanged even if there are a few outliers, as long as you arrange your data from the smallest number to the largest. Effects of the outliers on the mode. Unless 2 or more of the outliers are the exact same value, the outliers will have no effect at all on the mode. However, if 2 or more outliers are the exact same value, these outlier values may be the mode, depending on the other data values. And there's a note in your notes that says outliers affect the mean, median, and mode differently. This is because it's bad English on my part there. Because they calculate central tendencies differently. They affect them in different ways. If you are very familiar with how they're going to affect example 2, you'll see. Now, example 2 I didn't write on the board yet, but I will do that very soon. Example 2, outliers. Juanita received the following pledge amounts when she participated in a Cure Cancer Walk. $10, $20, $5, $12, $5, $8, $5, $70, $5. Which measure of central tendency best represents the pledge amounts that Juanita received? So we look at median. And what I did right away here is I put the median, we're trying to find the middle value. I put them in order from the smallest value to the largest. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data in that data set. Just double checking. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The median would be 8. Now the mode is which value appears more than once. Now you can have more than one mode, but in this one here, I think it's pretty obvious that the 5 appears the most, 4 times. So the mode would be 5. The outlier is which piece of data is there that really sticks out. And in that piece of data set, out of those pieces of data, the outlier would be the $70 donation. That is your outlier. Now the question doesn't ask for mean, but if you were to do the mean, you would take all your pieces of data, all 9 pieces of them, add them all up. The 5, 5, 5, 5, 8, 10, 12, 20, and 70, and you would add them all up. Now if you include the 70, you're going to get a mean that isn't going to be correct. So what would you do if you were to do the mean correctly for that one there? Well, if you wanted to do the mean, you're going to be doing something called a trimmed mean. And we're going to show that soon with some examples. So now we're going to work on an example that involves trimmed mean. So a trimmed mean is basically where it's also known as the 10% trimmed mean. This is where you ignore the outlier or outliers in a data set. Now what it means is that if you have a data set and you have an extremely high valued number in the data set, that's most likely going to be the upper level data that's going to be removed. Now, if you have an extremely low piece of data, or just a low number data value, that will also get removed. So a trimmed mean is where you take the highest value and the lowest value and you omit them, which means you remove them from the data. So example 1, which is already done, there's a set of numbers there. Now I'm not going to read them off, it's basically going to take time if I read them off on the camera. So you have a high number there in that data set, and it happens to be a number that you're going to remove. And it's 156 because it is considered the extreme highest level value. It's the upper level outlier. Then you have the lowest value. And the lowest number in the data set is actually 32. So for step 1, you look at your data set to locate the outliers. And we have the 2 of them. you have 32 as the lowest and 156 as the highest. Now, by taking those two pieces of data out of your data set, which was at one time 20 pieces of data, now becomes only 18 pieces of data that you're going to work with. So then you go to step 2. With the outliers removed, you can now calculate out the trimmed mean. You would add up all the numbers there that are still in your data set. When you add them all up, you would then divide by the total number of, well, total pieces of data, which would be 18. In this case, it's 1,571 divided by 18, which gives you a trimmed mean of 87.3. I will do the exact same thing for example 2. And actually, you know what? I might just keep example 2 rolling, because I'm not going to do the full set of math and write all the numbers down. Maddox wants to run the 100-meter race at his school's track event. To find his typical race time, his physical education teacher is deciding whether or not to use the mean or trimmed mean. Over the course of a month, Maddox has run 20 races to determine if he will qualify for the track team. Maddox race times are all measures in seconds, and they are listed as follows. You'll notice that if you look at the numbers, they're pretty close to each other, but there's going to be two pieces of data that just stand out as being extremely low, or one piece of data will be extremely low, one will be extremely high. So what we need to do for example 2 is find the mean of Maddox race times. Now, that's just using your regular mean. You add up all the numbers that you see there. And it ends up becoming that if you add them all up, you're going to get 253. You're then going to divide by the total pieces of data there, which would be 20. And that would give you 12.677. 12.677 seconds. Or 12 points, if you want to round it up, 12.7 seconds. Now, to do the trimmed mean, you're going to take a look at the data, and you're going to realize that we're going to omit, which means remove two values: the lowest value and the highest value. In this case, there's going to be a 13.75 and an 11.67. You remove them from your data set. You don't want to see them. So if you want to cross them off, you can cross them off, and then you have your data that's going to be working for you. Now, because there are 20 pieces of data there, you're removing 2 of them, you're going to drop it down where you now have 18 pieces of data to work with. So what you do there is then again, you would now take and add up all the times that are there again and divide by 18. So which value should the physical education teacher use to determine whether Maddox makes the track team? If we look at what we have now, we should get here, for example 2b, your trimmed mean should be along the lines of 12.67, I do believe. 12.673. The original value with the outliers in it was 12.677. A slight bit of a difference there, right? Should the physical education teacher use the mean value or the trimmed mean? The trimmed mean makes it so that he is slightly faster by what, 5 thousandths of a second faster. So in this case here, Maddox times are fairly close and consistent. It doesn't matter which mean, median, or mode used, or even trim mean. It's not going to make a huge difference in his time when you think about you're going 3 decimal places. That's kind of the reason why I kept 3 decimal places here, because trim mean will only drop you down by 5 thousandths of a second difference. But it might make a bigger difference if the outliers were a little bit larger, or there was a big separation between the smallest valued outlier and the largest valued outlier. So that is considered trimmed mean. A little bit more about mean, median, and mode. And the new one of trimmed mean. The outliers and trimmed mean assignment number 1, which will be part of this package digitally that I sent you, you're going to have to tell me for questions 1A and B what the outliers are. Question 2 will also have a very similar idea where you have to figure out the mean. If you remember from yesterday, Monday, January 11th, we did a restaurant activity where you had to find out what the employees made. There's a hint that this one's very similar to that. You have to figure out the mean, which is the average income of all the people in the room, including the outlier as part of that data. Then 2B says, well, what's the outlier? It's pretty obvious which employee or person in that business makes the most. If you remove the outlier and then you do the trimmed mean again, you're going to find the correct average that you want for what the employees make in a year. Then there's question 3, a survey of donuts that kids eat, or how many they eat in a week. That one's pretty easy. You have your data. You might notice that there is going to be easy outliers there, a low number and the highest value number. Then question 4, I'm going to let you try to figure out question 4 for mean, median, and mode. Question 5, I think 4 is actually harder than question 5, the annual salaries for employees at Don's Plumbing Store. You take a look at your data set. You figure out the regular average or mean, including the outliers or outlier, and then you look at question 5B and say, okay, what's the outlier data in there? Remove it, and then figure out your trimmed mean from there. Margot, a woodworker from Moose Lake, question 6, again, it's the same thing. Figure out the regular mean, including the outliers or outlier, and then remove the outlier or outliers and do the trimmed mean again. You may have both a low number and a high value number, or you may only have one, but in most cases when it's 10% trimmed mean, you take away the lowest value and the highest value. That is Statistics Lesson 2, Topic 2, Outliers and Data.